One of the most important thing in machine learning is features. Uh, most of the kind of if you see the sciences, they are kind of database centric. Machine learning is also database centric. So yeah, if I have a kind of a set of data, then data has features. Like I have a set of people. So I have a database of people, and this database has features: name, country, height of the person. There can be many. So if we see kind of features in machine learning, then what we guess? If I have these two features, if I have a kind of the scenario is these two features are available, then what is the probability that it will belong? Then among these two, the third feature will be X. Like a person, each person has three features. He belongs to a country, he has a name, and he has a kind of height. Now, if I say the name of a person is Joe and his height is 6 feet, then what is the kind of probability that he will belong to Egypt? A person whose country is Egypt and his height is 5 feet 8 inches, what is the probability that his name is Joe? A person, his name is Joe and he belongs to country Egypt, what is the probability his height is 6 feet 2 inches? So if we see machine learning, it's a game of features. Means how much feature rich the database is, and then kind of if I have a set of features, then getting the probability of, like if I have set of if there are total n number of features, but anyway I have set of x features, then what is the probability that this set of x feature would belong to a feature called y? Okay, so we'll see in Bayes' theorem. So Bayes' theorem doesn't talk about multiple features. Two features, two planes. Okay, so if I have a database and it has two planes, and if it has two planes, in one plane now it has items, in another plane it has items. Like a person has a name and country. So country plane has countries, name plane has different names. Now there are high chance that there will be intersection. A particular country may contain a few names like that. Now question is that if I know that a particular country has a particular name in this much percentage. Okay, I know a particular country whose the country's first, what is the probability of a particular country in that plane, and then in that country, then the particular name like Joe has this much percentage. In another plane of the name, if the Joe has 1% in that plane, inside Joe, how much will belong to that country? In one plane, if I have an item, inside that item, in another plane, one item is placed inside that. If I do orthogonal, then in that plane, in that item, what is the percentage of this plane's item that is? So that is kind of biased. If two kind of features are orthogonal to each other, then if I know one feature's probability in other, then what is the reverse? Okay, so that leads to bias. But anyway, if we go to general probability, okay, so if I just consider it. So we create a sample space of the actors, means what is the sample space, and then we pick what we want. Okay, like if I say that a person name is Joe, and then what is the probability that he belongs to? He is Egyptian Jew. Joe can be belong to many countries. Now, what I have to do is I have to just count how many Joes are there. In each Joe there is a tag of the country. Just count how many that. So this is bias theorem. Two features orthogonal, name and country. Okay. So inside the country, if I know the percentage of Joe, then inside the Joe, what is the percentage of that country? So two orthogonal plane. In once, if I know the probability, then what is same thing probability in other plane? Okay. So we will proceed more on kind of bias theorem now. Okay. So what can be the a scenario in multi-plane? Now, like if I say there is a plane of country and name, now there is another plane of height. Okay. Now, a person name is Joe and his height is 6 feet. What is the probability that he belongs to Egypt? So now I have in sample the actor is Joe and height. So I have to create all the sample space where the name is Joe and height is 6 feet. All name and Joe and height is 6 feet. There is no feature like that. Feature is only 3. So this is the hybrid plane that is coming into the picture. Now this hybrid plane and plane of country, how much they interact, because bias theorem talks about two orthogonal. So we'll create another plane, hybrid plane, where name is Joe and height is 6 feet. Then inside that we'll pick how many belong to Egypt. Okay, that is one scenario. Another scenario is what about this is information means if I start getting anyway means this is simple in the sense that now I just iterate through the database. So if a database is of people, then it has 3 features. So all the features which is name is Joe and height is 6 feet, then I'll kind of list down all the features. Against that I'll just find out the tag of the Egypt and then I'll just divide and I'll get the kind of probability. Okay. Now scenario is what about there is no Joe and height is 6 feet. Okay. If that is the case, then what is the probability? So now I prepared full database. Now I am looking for a Joe whose height is 5 feet 11 inches. 5 feet 11 and half inches. That information is not there. So what is the meaning of creating sample space when it is not available at all? So in that plane, in that kind of hybrid feature plane, there is nothing. So means it is meaningless to proceed. What are the solutions in that scenario? First, we see that bias theorem is for 2 planes. Now, if we are looking for one plane, then what we are providing as input scenario, that will create a hybrid plane. Now, there are 2 planes. Now, next scenario is in hybrid plane, there is no item. In that scenario, what we can do? So, one scenario is we can do kind of a grouping, like a person whose height is in integers like 5 feet 9 inch, then 5 feet 9 inch and half, 9 and quarter and 3/4. So all fraction will come in 9 inches, like 6 inches, 7 inches, 11 inches. So it's a kind of binning or grouping that we do. So in that way, we will get a sample space. Okay. So if a person is available of height 5 feet 11 inches and his name is Joe, and I'm searching for a person whose height is 5 feet 11 and half and his name is Joe and he belongs to Egypt. So in sample space, now all the 511 point all will come. So at least I can create the sample space and then I can kind of think about then picking out the country as Egypt. This is one scenario. What is the another scenario? So there Bayes' theorem hits. So if I say that a person name is Joe and his height is 5 feet 11 inches, what is the probability that he is an Egyptian? Okay. So now I would rather say the first in sample space we first kind of try to get how many people have named Joe and his height is 5 feet 11 inches. So, okay, so what information I have? Per country, okay, like Egypt, then we have kind of Nigeria, France, or we have Canada. So inside all those countries, like we have China or we have any Central Asia country. So in our country, we will find that if there is Jew and his height is 5'11" and any kind of point. So now per country, so first idea is we have to find how many people in full sample space their name is Joe and height is 5'11" and it's kind of it's a fraction. Then per country wise we have to find what is the probability that name is Joe and then what is the probability that this is the height. Okay, that way we create the sample space. Now we know Joe and height is 5'11". What is the probability that he belongs to Egypt? What is the probability of a person belongs to Egypt? So that I have to know. Then inside Egypt, so inside Egypt again feature by feature, I have to find the probability and then we can multiply and then we get the probability of that feature in that country divided by every country's, so the total number of samples. Okay, so if we see kind of two approaches. First is finding the exact sample spaces and then exact kind of in sample space exact what we are looking for. That is one scenario. Then we do the binning or grouping, so to increase the probability. Third is we go by feature and then it is like independent event, like if I toss a coin 3 times, then 3 independent event happens. Then we keep multiplying the kind of event probability and we keep getting less and less and less. Okay, this is kind of one flow that we get in the Bayes theorem. What is next? How? So like if I say that my sample space is this big and inside that I have to pick this. So this is the best one. Means I know that in my sample space whatever we need, those items are there. Inside that we can pick what we is the required. Next thing is, so this is the best thing. Next thing is, it is not available. Then we can do binning, grouping. So in a group, we will group the feature items, and then we will try to create sample space and we will try to find out. Obviously, this will be kind of less probable. If it is not available, then again per class wise we will go, and there feature wise we will as an independent event. Then we will calculate the kind of probability. So now idea is if I proceed this way, then slowly the kind of the result, we can say accuracy of the result will kind of diminish. So now we will see that how nicely we can kind of proceed. So learning process of the Bayes theorem, the algorithm, or I can rather say the data structure that we fill, we create the model. So how we can make kind of learning process in a way, in a quantized way, that first, second, third, from the third scenario also, we can kind of reach the first scenario. So those things we'll see. So multi-feature, and then in multi-feature, multi-planes, that we have to create hybrid plane and come up with the 2 plane, and that if we don't get the exact sample space, then binning, and then independent event, and then how things we correlate, so that kind of a maximum result will get. Then we will kind of try, like it's a famous, like if I have a set of documents, like one is talks about horror stories, and one talk about kind of love story, and one talk about social kind of information, one talk about patriotism, and there are so many classes that books are divided in. So first we'll make it learn the the model, then we can place any book and we'll see if it really belongs to what we are looking for. So that means. Okay, so what is the problem in a kind of bias theorem? So whatever we have seen, like in okay, so bias theorem, we know that it talks about two planes, and we have like we have a database, and database has multiple feature. Okay, more feature a database has, it is feature rich, and database can be now kind of it is further disintegrated into the individual items, and individual item now kind of has three features. Okay, so individual items kind of it may have various planes, like it is grouped together in the context of height. Okay, so now we see like if there are three planes, red, green and blue, and blue plane is country plane and red plane is name plane, whereas the green is height plane. Okay, if I talk about only two planes, that is the country plane and name plane, and inside the country, if I know the probability of Egypt country, how many people are staying in the Egypt, and inside the Egypt, if I know the probability of name Joe, then what is the probability inside the Joe that is hooked inside the Egypt? So this is called kind of orthogonal, two orthogonal items. Orthogonal in the sense that country is in country plane and Joe is in name plane, and then if I know this intersection in the respect of an item in country plane, what would be the percentage or probability of this intersection in the context of name, a particular name in the name plane? So that is kind of bias theorem. Now we can go with multiple feature. In that case, we have to come up with a kind of new plane. Okay, so if I say if green is a plane, inside that this is an item, and inside red, okay, so white and red, what we see intersection, that is a common intersection. Now we have a blue plane, inside that another blue is an item, and then altogether the red is the common feature among everyone. But anyways, so what if I talk about a dual plane in bias theorem, whereas we have three planes, then we can say that if I know the probability inside this green for this kind of this dual intersection, red and white, okay, then in dual intersection plane, how much it is hooked inside the country. So that is, so we kind of we are thinking about a new plane. So what earlier we were talking is like if there is a, if I know the probability of J, then what is probability of EJ? So if I know the probability of J, then what is probability of EJ? So that is calculated. I should be knowing probability of E and then inside EJ. So if I want to know that I have a kind of happening H and J, then what is the probability that H and J inside E? If that is the case, then I should be knowing the probability of H and J, and then probability of E, and then inside D HJ. So HJ is coming as a new kind of hybrid plane. So we can kind of simulate that. Okay, so we have kind of 3 planes. So 0 plane, I can take it out, and then 1 first plane. So I would rather say we have kind of 3 orthogonal planes. Okay, so we have kind of 3 orthogonal planes. I think this would look even better. Okay, so we have 3 orthogonal planes. Now, Bayes' theorem, when it talks about only 2 planes, so we can think about like in this case we have HJ, height, and name is Joe and height is H. Then we are thinking about one more plane. So we can have one more plane. So we already have 3 planes. We'll have one more plane. Probably we can think color as yellow. Okay, so now we have one more plane. So this is okay, so we'll see. So okay, so we have 4th plane, that is yellow plane. Okay, and now story is earlier story, so red and green. So green, okay, so green is kind of country. If I am considering green as country, then we are talking about green and yellow. So blue and red kind of they become hybrid and they generated yellow. So that could be even better if I do like this. Okay, so blue and red, they created a hybrid plane yellow. Now story is between yellow and green. Now we consider yellow and green as orthogonal. Then a hybrid plane green has come, and that is the height and J, and then story is between yellow and green. So story is between country and H and J. So new plane comes into the picture. So this is what we have discussed. Okay, now as per the probability we have kind of seen, we find the actor, and then we create sample space, and inside that we pick what we want. This is the basic fundamental of probability. So if I am looking for a name and height of a person, and if name and height is given, then what is the probability that he belongs to a particular country? Then name and height sample space we would create, and then it would belong to, everyone would belong to a country, then whatever country we are looking, so that so count is 4 and divided by those many in the sample space. So that is the probability. Okay, now question arises when whatever we are looking for, like I am looking for a particular N and H, if that is the scenario, then it belongs to which country? N and H is not there. Okay, so I am talking about name is Joe, the example we are taking. Name is Joe and height is 6 feet, so that is available. Now I am searching for a Joe whose height is 6.11. So 6.11 and Joe, so there is nothing like that. Okay, if that is the scenario, then how we proceed? Okay, so what is the situation when we have kind of this kind of situation where name and height a particular combination? Okay, so we can say like a coexistence. So coexistence is not available. If coexistence is available, then we can get kind of perfect probability. If coexistence is not available, then how we would proceed? Okay, one idea is binning. We can bin like a name. If kind of common names are available, then we can, or I think we can just leave the name as it is. Height we can bin. Okay. Okay. So height we can bin. Height we can bin in a sense like people who are kind of 6 feet 1 inch, they would come in one height. 6 feet 2 inch, they would come in another height. So when I say 6 feet 2 inches, that includes 6 feet 2.1, 6 feet 2.2. Okay, so all kind of fraction inside that. So this may be 5.1, 6.2, 6.3, 6.4 like that. So more fractions we are not including, or we can take height as 5 feet 5 inches, 6 feet 5 inches, 6.7 inches like that. So we bin all comes into a particular group, they will constitute like a equal height. If that is the case, then we are able to kind of probably whatever our scenario is, we can get again, we can create a sample space again with the binning. So we create the more probability in that sense. But we would lose the feature. Whatever feature we used to contain, even if we bin it, we lose the characters in that fashion also. Okay, what is next probability? Next probability is count based, or even if we bin it, okay, so we can call it as independence in probability. One was binning it and directly jumping to the kind of number of items in the sample space. Rather than that, we can go for individual probability. Okay, so probability of n individual, probability of h, we can bin it also. Even after binning it, we will go for individual probability. We will not look for kind of coexistence. Okay, then still we can create the sample space. If that is the scenario, we still lose the characters. I mean the features. Okay, what I am talking is, now earlier we were talking about if person name is this, height is this, then he belongs to a particular country. So probability of coexistence of N and H, and then probability of a country, and then inside the country what is the coexistence of N and H. Now if we talk about the independence, then we plainly compute the kind of probability of particular name in a global space and probability of a height in the global space. Okay, like, okay, so we can see like if okay, so if I am looking for a particular name and number of people are kind of 100 and particular name is 5, okay, and particular height is again 10. Okay, so what we are trying to say is, Okay, so what I am trying to say is that if name is, if number of people are 100, if name is 5 particular name into height, so height is kind of 4 people, they have height what I am looking. So it would come like 5 by 100 and 4 by 100. Okay, even if we had 2 in common by luck, then it would have been 2 by 100. Can we see how much we are losing the character? If we go with independence, then 2 by 100, if I was getting through the 2 by 100, I was getting through the coexistence, probability of NH. If I go with the independence, okay, if I go with independence, then now 5 by 100 into 4 by 100. So that will come kind of 20 by 100 by 100. So it is, we are losing the characters heavily if we go for independence, but still we don't have any choice. If whatever we are looking, it is not available. See the scenario. Like if these are the samples, and if I say the name of the people are colors, and these are the height, and I want people with the name blue, and people with the name blue, and their height is 5 feet 5.64. Even if I bin it, then it will come to 5.6. Then there is no person with name blue and 5.6, but still, okay, still we are getting the, so there is a kind of error. If we go with the independence, either, so we lose the information. Idea is, even if we go get more probability or we get less probability, whatever the sense, we lose the actual character. Okay, so 3 ways we talked. One is kind of getting the actual coexistence, like we saw the different plane as yellow one, and then if actual coexistence it doesn't exist, then we go for binning, and inside the binning also we can go for, if we don't find, then we could go for independence in the probability. If we go for the independence in the probability, we start losing the character. Okay, so what is the scenario now? Independence probability to coexistence, co-probability, how we can achieve, how we can get back we can go toward the actual characteristics. Okay, so that is a big question in Bayes theorem itself. So, okay, now earlier we had P and H. Okay, now if I talk about the independence in the probability, then we have to kind of, there are multiple passes. Earlier we had coexistence. Inside coexistence, now we came to independence, so it became Pn separately and Ph separately. Okay, this way we lose character. So we can go class wise. Inside a particular class, what is the kind of probability of N and H? Inside another class, what is probability of N and H? Inside another class, I mean another country, what is the probability of N and H? So this is the best one if we get. Otherwise, we can go kind of in global, what is the independence probability of N and H? Okay, but we lose the character in this fashion. We saw that. Okay, it is too less, or it gives error. It is error prone. In that case, we can go kind of a country by country, and then we calculate the probability of N and H to get independently, and we keep adding it, divided, and the numerator would be the for the country what we want. If we do in this fashion, okay, then we will be more close to the co-probability. Even with the independence probability, we will be more close to the co-probability, coexistence in the probability. Okay. Can we think more? What I am trying to say is that, okay, so I have, this is a global case, and inside the global case, there are 4 classes, 4 countries. Inside the countries, we have name and height, so we have people inside the country. If that is true, okay, now let's say that I consider this color as kind of a purple. Okay, how many names are there whose name is purple and height is 6 feet? Okay, now if I go with the kind of global probability, okay, so better I should paste it here also, so that it should be like continuous what we are discussing. Okay, so now what we are talking now is that if we think that what we want, so the scenario is we want name of a person whose color is purple or brinjal, whatever is near to be seen, and height is h6. Now this is my question. If a person name is purple and height is h6, what is the probability that he belongs to a particular country? So if that is the scenario, okay, so this is the query, that if a person name is purple and his height is 6 feet, okay, so his height is 6 feet, then what is the kind of scenario that he belongs to a particular country? Now, if I go with the independence, then how much we get? Pn, number of people, they belongs to in the global space who is purple, so that is 2. 2 by 12, there are 12 people, 3, 3, 3, 3, 12 people, 2 by 12, into height, so there are 2 people, h6 height if I see, then, so purple are 2, and height are 2, h6, so that would come as 2 by 12 into 2 by 12. So I believe it will result in 1 by 6, 1 by 36. Okay, if I take class wise, then H6 purple belongs to a particular class only, and that class probability is 3 by 4. 1 by 4. Okay, and then it is 2 by 3 inside that, plus, now this is one class, Okay, now okay, otherwise purple is not available anywhere else. Okay, so that is the scenario of this. Okay, now we'll see for the kind of okay, so okay, so the probability of a particular class is 1 by 4, and then probability of a purple is 2 by 3, and then probability of H6 is 1 by 3. Okay, now this is available in another, so it is available here. So whatever is available per class we are calculating. So that is 1 by 4. Okay, okay, 1 by 4 into how many kind of purple is there. So purple is not there anywhere. So it would come to like this much. Okay, so if I proceed with this approach, then it would be like 1 by 80. Still it is better. Okay, now think of a scenario where H6 is also inside this. Okay, or there is one more, or it is like this and it is like this. If this is the scenario, then if we calculate now, one by 4 okay, 1 by 3 1 1 by 3 into 1 by 3 plus 1 by 4 into 1 by 3. Let's see how much it 1 by 3 into 1 by 3. Okay, so if I add these two, then it would come like 1 by 2. How much it will come? 1 by 2 into 1 by 3 into 1 by 3. So that would lead to kind of again 1 by 80. Okay. Still it is better. Can we see? Now we'll think about another situation. Now everything is inside 1 only. So let's consider this. Okay. Now we'll proceed. If that is the scenario, then the probability would be 1 by 4 into 2 by 3 into 2 by 3. If that is the case, then it will lead to 1 by 9. Far better. So, when we go for kind of independence in the probability, idea is when we go like if we see the coexistence, if it is not available, if we go for with the independence in the kind of in probability, then rather it is a good idea to go class wise or country wise country rather than going globally. In global fashion, we lose lot of information. In that way, we can go class by class, and then inside that we look for the hybrid plane. So, hybrid plane we look as independence probability in particular class and then class by class. Okay, so this is kind of if we do this, then we kind of from the independence probability we will kind of move toward the more reality. Okay, can we think more? Now, if I have a class and inside the class this is a new plane, name and height, can we again kind of group in something like this? If that is the situation, then the numerator what we are saying, so probability of the class inside the subgroup probability and then name in the subgroup and height in the subgroup plus name in the another subgroup and then name and height in the another subgroup. So, what we are trying to show now means now if we have kind of groups, if we are looking for a kind of so class whatever we have given as a white circle, so this is a kind of I should have given green circle. So that is the green plane and yellow plane, that is the hybrid plane that is arising, that is from height and name. So two planes, one plane what we see as a white circle and then these are the intersection that is coming as a hybrid plane. Can we think about mode hybridization? Like if we are inside a particular plane like a class plane and then we have the characters like this, can we group again? Okay, so this can be used in kind of a learning phase. So when we learn something, so we can learn as a group. We cannot learn at three items, kind of three co-features. Together feature they come and assign to country. They can come in a kind of a group. Okay, so idea is that if they come in a group, then we can have more localized, more fine information in this fashion. So if I am calculating numerator like this, then denominator can be calculated like that only. Computation would grow, but it would not grow that much that we cannot calculate. And so when we kind of train the model, so while training, if I train a particular plane, so there are 4 planes. I mean, if I train a particular plane, inside the plane, if we train a particular class or particular country in our example, then we can push in batches. Okay, whatever the data we push to make the class learn, we can push in batches rather than individual. If we push in the batches, then computation is more localized. If it is more localized, then we are more towards the coexistence of the probability from the independence probability. So, means it is kind of more realistic. Okay, so we will have kind of a lab session. So in that it is kind of we have documents. Okay, so I think we can copy this in lab session. So how much we have? Okay, so in lab session, we'll see like we have a okay. So in lab session, we'll see like we have separate classes. Okay, so these are classes. Okay, so we have separate classes. This is one class. Class of documents. One is, okay, one class belongs to kind of thriller. So novel, which is kind of, it is a thriller. Another class can be like something like kind of art kind of thing, artistic. So these are class of documents. Okay, so all class so these are class of document. All document belongs to a particular class. They are artistic, or they are thriller, or they are kind of suspense, or they are kind of horror and comedy or something like that. Okay, so that we'll see. Now if I bring in any particular document, okay, so happily now I am kind of bringing a document, new document. If I am bringing a new document, then this document would belong to which class? That is the question. Okay, so this document would belong to which class? So if I push a new document, it would go to which class? So that we'll see. Okay, now what I'm trying to say is, when we make it learn the classes with the document, we remember the document. Okay, document had words. Document has words. Words makes a document. Rather than pushing all the words inside the class, we can remember the document inside the class. If we do so, then inside a particular class, we have subdocuments. And if we try to find a new document, then it will be easy. Okay, so that we'll see.